Hello everyone, my name is Thomas Castner. I'm the CEO and co-founder of FlashPCB, and I'm here to tell you this story about how one board, one PCB started a company. So before we get started though, I just want to say we are hiring, so if you are looking, please come talk to us. We'd appreciate that very much. We're also looking for beta testers, so if you make PCBs, also please come talk to us. We're happy to do a little demo for you if you'd like. And also, please ask questions as well. We're excited to answer any of them, so people have done a good job of that so far. So what is FlashPCB? Well, thanks Mark for these words. We're a fast, affordable, and hassle-free AI-powered PCB assembly service. So our goal is to create actual instant checkout and actual instant quoting for PCBs. And our eventual goal is to do a 3-day turn time. So if you design a board and have it finished on a Monday night, you could order it and it'll show up on your desk Friday morning assembled. It's a little bit ambitious, but right now we are kind of in our beta phase, so a little bit about where we are right now. But so our beta phase, we're a little bit slower than that. We're at about 3 to 4 weeks. We are 4 full-time employees, and we are currently NSF SBIR funded, which is great for us. We're actually based right there in the corner as well. We do our manufacturing. Some of our manufacturing occurs here, and some of it occurs actually with a contract manufacturer up in Levittown, Pennsylvania. So we're very local. So if you are local as well, it's much faster for us because we can actually hand deliver stuff to you as well. So a little bit about myself. I'm a graduate of Penn. I'm a real Philly person, grew up in the suburbs. After graduating Penn, I went and worked for a giant software company, SAP, 60,000 person company based, well, at least based in North America out of Newtown Square. But I really missed making stuff. I was actually a mechanical engineer at Penn, not an electrical engineer. So I built tons and tons of stuff, and I was really missing that. So I did what any good person does when they're missing something like that. They go back to school again. So I went to Carnegie Mellon, worked in one of the robotics labs there. We built multimodal robots. It was a lot of fun. But my lab moved to Germany and wasn't quite ready to go with them. So I decided to make it just a master's degree instead of a PhD, and started my hardware track, and started basically my hardware startup boot camp with Gridless Power. This is a battery company based out of New Jersey. There's the 4 of us there with some of our first products going the door. We built these 1,000 kilowatt portable batteries. They're used by EMS, they're used by the military. They'd be rack mounted for folks. They could be portable, like these ones are actually in a case and portable here. And this is where I first really learned to actually make electronics. So I actually brought my first PCB that I ever designed with me. So I'm very proud of this one. Like all good first PCBs, it has a jumper wire. So you remember the first time you design a board, don't forget to miss a trace. And it actually ended up in our production line, which is kind of cool. So your first PCB is actually out there in a real world product. We've built over 1,000 of these gridless cores at this point, and actually just this year, the product was finally retired. Gridless Power is still around. There are about 12 employees now. They make a different product called the Sentinel, which is a battery-powered wireless camera system. But anyway, still going well, and very proud of sort of the work that we did there. The second company I worked at, and this is actually based over in the Science Center, and they have a 2-part sort of history to them. They were called Optofluidics at this point, and we built one of the coolest tech products I've ever seen. We actually built a device that captured nanoparticles in a laser beam. Felt like science fiction almost at this point. But we had a little wafer that we etched a fiber onto, and then we shot a laser beam into it, and we actually watched nanoparticles get attracted by light and bounce along this fiber. And we had a couple questions today about or a couple presentations about product market fit. We actually had great product market fit. I think we had 100% market saturation. We sold all 7 customers in the entire world that would want to buy this. So, there's always questions about, well, what's your market size? But this was actually a great education for me in terms of customer discovery. So one of the things that we did was we went out and we asked every single person that wouldn't buy that device, why wouldn't you buy it? And we ended up developing this. This is called the Horizon. It's a device designed for counting subvisible particles in biopharmaceuticals. This is it was a very different technology. We invented a few different things. One was called background membrane imaging, where we would suck fluid through a filter, and we would actually have an image of the filter beforehand, and then when particles landed on it, we'd take a picture afterwards, and we could subtract out all the little round holes for the membrane itself, so we wouldn't count them as particles. We also invented something called SIMI, which is side illuminated membrane imaging, where we actually illuminated from the side, and we could see the edges of particles that were sticking up. This is actually a naked one here. This is one of our very first ones ready to go out to a customer. The company's now based in San Francisco. It's about 30 employees, and actually very proud of this. One of the first commercial applications of this was Moderna in development of the COVID vaccine. So it's cool to see it actually being used. And every major pharmaceutical instrument or pharmaceutical company owns one of these instruments now, and there are about 3 other follow-on instruments based on the technology from this. So good story about customer discovery and product market fit. So also, I love interesting little stories. So a little tidbit, my favorite PCB. Actually, our 4th employee, Max, who just joined us, actually helped me program and build this when he worked with me at Halo Labs. It's a little ring, well, not little, it's 5 feet in diameter. It's a ring light for our booth display. And we made it segmented so it could get packed up, but it's 2,200 individually adjustable RGB LEDs, 5 volts, I think about 200 amps of power into it. So it was quite a lot of fun. I really enjoyed it. At full power, it was literally blinding, and it would shine right through that screen that went on top of it. So you gotta have a favorite PCB if you're gonna do PCB assembly. And finally, we'll talk about the last company I worked at before starting FlashPCB, and the PCB that inspired the company was built here. It's a Levy. We were based out of Pennovation, and we built 3D bioprinters. You can see a Levy 3 with the 3 core extruder heads there. And this company was sold to 3D Systems here recently. But it had a different version of customer discovery. So we'll talk about that in a second here. So this is the board that inspired the company. This is the a Levy extruder board. And it's used to power those little extruders that you saw on the front of it. And we'll walk through what it actually does. So their version of customer discovery was, let's get a consulting company to build us a nice sheet metal box in CAD and get a render of it. Then let's go sell that. So on the left is what customers thought they were buying. On the right is what was in our office. And this is when this is about 2 weeks after I joined them. And we needed to make some sales calls to let them know the product was real. So we made it work. It's got a few wires there, but one of the things that this sort of really put a pressure on us was time. So this was super time sensitive, and we actually already had some constraints with this problem designing this board. So the sheet metal was already in production because we thought that would be the longest lead time item, let alone integration. So we had our sheet metal set up already. We had a lot of time crunch, and we didn't quite have everything working just yet. So what we're going to talk about is, this is the Levy 1 on the left, and we're going to talk specifically about the Levy core print head. So inside of that core print head is actually a syringe. And we built it to bioprinter. We have to do some interesting things with the syringe on the inside. Most notably is temperature. So we need to be able to cool it to 4 degrees Celsius and heat it up to 160, which is quite a wide temperature range. You know, it's much easier just to make something really, really hot. It's a lot harder to make it hot and cold at the same time. But we managed to do it. So this is a little bit of how we managed to do it here. So on the sort of building it, on the far left, we have the inside, which is a kind of a copper core. And then we had a series of Peltier plates around it. And Peltier plates basically, as you run a current through them, they basically pump heat across them. So we could pump heat out of the core, we could pump heat into the core if we'd like. Then in the middle there, we actually have a heat sink on it. So once we pump heat out of the core, you gotta dump it somewhere. So we dump it into a heat sink. And then we have some fans that would run on it. So if you're trying to cool it down, we'd pump heat out of the middle, blow it away with the fans. If we're trying to heat it up, we would basically just turn it on in reverse, full power. One of the nice things about Peltier plates is if you run too much power through them, they basically just work as resistive heaters. So how did we drive that, and how did we sort of have the board that inspired a company here? So the critical parts down there I've highlighted is an H bridge. So basically you can have current going one way or the other way. It drives kind of almost every motor you see in the world. And then we have a little filter to make clean power for the Peltier plates. Peltier plates don't like being spiked. They like a nice clean current through them. So, but those other pens will be very hot. And that's one of the things we're very worried about, especially when we're as space constrained as we were. So this is actually the board in its mounting location on sheet metal that was already in production when the board was being designed. So it had to go there. It had to work with whatever heat constraints it had there. So we wanted to test that. So what did we do? Well, so what are the questions we wanted to ask or answer in testing? Well, can we actually heat and cool the extruder? And will our board basically burn itself to bits where it is? So what did we do? We decided we'd build a prototype, and that's kind of the answer, the solution every engineer I think would have. So this is actually I think this is Rev B. I don't have a picture of Rev A, unfortunately. But we need this fast. So the traditional solution for doing it fast is we'll hand build it. We'll order a board, we'll get it assembled, or we'll assemble it ourselves. This is purple, so it's from Osh Park, which is by the way, if you are hand assembling a board and not using our service, highly recommend Osh Park. They are fantastic for this. They're very easy to use. And so we built the first one, and it didn't quite work. There are some very fine pitch components on here. So there's a microcontroller on the top, and then a little H-bridge driver on the bottom. And they were really hard to solder. So our testing no longer became about, does the design work? It became about, did we build it properly? And that is sort of not a question, that's not a question that we need to answer for this. The questions we really want to answer are the ones at the bottom. So we spent many a days wondering, did we solder the H-bridge properly? Is our microcontroller pins connected? Is our CAN chip on the proper way? Did I place the right parts on the board? Why is the board shorting out right now? That was a bad one for the first one. So I did what any engineer did. I said, well, let's try getting it made somewhere else. Let's do the normal production path. So that way we don't have the same hand-built problems that we're having on all these. So I got a quote back, and this is my best one actually. It was $3,500 for 5 boards with $25 of parts on it and 1 week lead time. And we got it. This is the best you can get in the US, basically. But it was so pricey that we decided we would build it again. So we built, Rev B at that time. And that didn't work. And then we built a Rev C. And at this point, we decided we needed to get it made externally. And then you built a Rev D for $3,500, and a Rev E, and a Rev F. And it adds up really quickly. And it took a lot longer than we would really hope. And so we started asking questions, which is, James, by the way, a great thing to do, ask questions. Why? Well, before we do that, I just do want to say that it actually had a good ending. This is the first one to go out to a customer, so it did actually work. and it didn't look like the first image. But we started to answer those questions why, and it kind of inspired me. I kept it in the back of my mind and was the inspiration for FlashPCB. So one of the things we found out very quickly in the process of this is that everything in the electronics world in terms of quoting and everything in terms of design rule checks are all done manually. So even if you go and use something like a PCBWay or a JLC PCB, they might give you a quote up front, but that's subject to change. So they actually have a person go and look at it. Same thing here in the US, although you won't get a quote right away. They'll make you wait 24 or 48 hours to get a quote. And then everything, including, one of the questions we had for our manufacturer of this board was, well, we paid $2,000 of our $3,500 was to get a panel in 2 days. Well, it takes you 1 day to make run it through their service mount line, so why didn't we get our board in 3 days? Well, it turns out they need the panel first before they go to program the machine, because the guy programs it based on the panel, not on the data points that we give him. So it seems like the industry is kind of stuck in the 90s. And that is where we come in. So what we do is a little bit different than everybody else, is we are much more focused on the parts themselves as opposed to trying to have every board feature you want. And the way we do this is we actually give people a library of parts. So right now we are primarily focused on Eagle. We have 1,600 different footprints available to you. Those are footprints that we know are good. Those are footprints that we know the orientation of. Those are footprints that we know what parts go on them. The other thing we do is we actually work with CAD files directly. So there's no more exporting a Gerber file and having a manufacturer wonder what unit is your Gerber file in, even though it's right there in the file. Their software just doesn't tell them that. And also, we actually create a bill of materials for you. We have a very fancy AI algorithm written by my co-founder, George, that basically takes your footprint, takes the value text. So if you have a resistor, maybe 100K, 1%, it reads that in, understands that's the resistance you're looking for, the tolerance you're looking for, understands that is, you're looking for the closest resistance possible. Your tolerance probably needs to be less than one, you can't have a 5%. You don't want 5% for your tolerance, you want 1% or less. So we know that is the way that sort of the hierarchical equivalence, technical word for that. And we also match that to parts that are in stock or available. So there's no email back and forth saying, hey, I can't buy this component. We'll only show you components that are available to us. And this AI bomb generation is really important because every manufacturer I've worked with has given me a board that's missing, there are 30 resistors on it, or 30 capacitors typically, and the Excel file for the bill of materials I give them, they haven't expanded that row, and they only see R1 through R5, and they miss the fact that R6 through R30 is hidden. So yeah, we don't have that problem anymore. The other thing it lets us do is do instant quote and instant checkout. So because we read the board in, we know exactly how big it is. We also do a design rule check automatically, so we know we can make it or not. That way, you're not waiting 2 days for us to come back and say, hey, we can't actually build that. And then because we know what parts are going to go on there, prices are relatively well known, we can actually give you a price right away, and it's the correct price. And so the idea is that on Monday night, once you finish designing your board, you press order, and we don't talk to you again until Thursday night when it ships, and we tell you it's shipping. So that's the goal. The goal is a 3-day turn time here. We think that our customer discovery told us that would be like a game changer, I think, for most people here. So we're excited to get there, but in the meantime, we are looking for people to test our beta service. So if you make PCBs, please come talk to us. Today, we're having a beta program sign up. So if you sign up today on this QR code, you'll be automatically entered into our beta program, and there'll be $400 in coupons in your account once you do that. So are there any questions?
Anyone with questions? And I've got the easiest question because it's dumb.
Okay.
So you make PCB boards, custom PCB boards.
Mm-hmm.
That was it, that's my whole question.
Yep. So we actually don't design them. So you will design them yourself, but we'll manufacture them for you. So you design a board and you want it built, we'll build it for you. And yeah, I think that yeah, I mean, if there are any questions on design though, in the like folks in here can ask us, but we will assemble it for anybody. Yeah. Go ahead.
I heard you say earlier that you had 1,600 components. Can you talk a little bit more about the limitations of your existing process?
Yes, so one of the biggest constraints that we see to this process currently, we're working on solving that too. We have some ideas in the future here, but we heard start not sexy, so we're doing the not sexy way to begin with, is having components. So lots of people will design boards and they'll have very specific components on it and they'll want that specific IC, typically it's an IC. But there are lots of parts like resistors. Like there's about 50 companies that make resistors and about 50 companies that make capacitors. And so part of our customer discovery, by the way, the first 6 months I started this company in January of 2021. My co-founder George joined me in August that year? Yeah, August that year. And I had basically spent those first 8 months just asking people questions. It's a great thing. We did customer discovery. So we went out there and asked people, do you care if we swap out a component for you? Would you be upset if it's a Samsung capacitor versus Panasonic? And the answer for most of those parts was no. For ICs, people did care. So part of what we have in mind is that, the first question we had was, well, how many parts do we need to sort of have a robust enough library that people can design stuff? So one of the first things we did was we looked at where people got their designs from. People said they ordered from SparkFun and Adafruit, which is really, again, cannot recommend those places enough. And so what we did is we went out, we found every single board that they produce on their GitHub. We scraped them all and put them through some software, figured out all the components they have across their entire range, including their test boards, by the way, not just the ones they make there's available for sale. And then we went through and manually figured out, well, what unique components do we need to fill those parts? And we actually ended up finding it's about 2,000 unique parts to make every single board that SparkFun and Adafruit has designed that's on GitHub. So it's not just the ones they make for sale. And that's lower than I thought, seemed achievable. But the part of the beta process is also growing that library. So as people request parts, we will add them. In the future, we do have a way, we're gonna have a process whereby people can request components. So one of the things that might involve putting a deposit down for parts in the future so we can bring it in stock, or if it's hard to find, we want to do that. But maybe it's easy to find and someone like DigiKey or Mauser holds it, maybe we don't need to do that. So that's kind of the limitation that's the biggest limitation we have, I would say. Yep.
Hi, Tom.
Hi, Isaac.
I'd like to say I'm very satisfied with the boards that I've ordered so far. I'm an early beta user. I have a question.
Yes.
Can you do 4 and 6 layer boards?
So for the beta program, we're doing basically 2 layer boards currently, and we will do 4 layer boards very soon. George is telling me that the software works for 4 layer boards right now. We found that in our customer discovery, again, we found that most people will be happy with a 2 and 4 layer board. By the way, Isaac is our first customer, so thank you very much, Isaac. So yeah, 2 and 4 layer boards, and we probably, in the future, 6 and 8 layer boards are very easily doable for us. We can do up to 16 with our software currently. But the question is there market demand for that? And we don't quite think so. Part of what we do is we batch boards together to make our manufacturing a little bit easier on us. And if someone orders one 16-layer board and it's 1 inch by 1 inch, I got to make a whole panel to do that. So that might not be the demand there for it, or it could be really expensive. We got to figure that out. So, thanks, Isaac.
Any more questions?
I got a question. So, where do you do the actual PCB fabrication, like the fabrication of the fiberglass?
So we actually have a broker here, and we actually do it in the U.S. So we have a fixed rate setup per square inch, so we can get that done here locally, or well, not locally to here, but in the U.S., which is good for us. We actually need part of what hitting that 3-day turn time is we actually don't have. Our goal is basically to be faster to get it from us than it would just to be ship it from Asia fully done. So that's kind of we have to be here. There are also other benefits to being here in the U.S. There are potential ITAR benefits, which helps us, have some more higher value customers. Part of our customer discovery also found that most board manufacturers in the U.S. primarily do military work. So there's always sort of a benefit to keeping that in mind as we develop the service.
I don't have maybe a question so much as an encouragement. You mentioned JLC, and I worked with them a couple of times this year. And while I'm impressed with their time and cost from order to delivery, there's a lot of work taking your design, figuring out what they have in stock, substituting in. Sometimes they don't have quite the same value when you can use the other value if you change these 3 other parts. So to the extent that you can automate it, that would be absolutely great.
Yeah, JLC PCB I think does a fairly good job with that. They're the closest ones I would say to having that process down. But yeah, it's manual unless unless you put their part numbers in your BOM when you upload it, which is essentially a manual process as well. We kind of want to be as easy as Osh Park is, so where you just basically upload it and it uploads all those details for you. So, Mark.
You showed us a previous slide that the best you could do for 5 boards was $3,500. What's it going to be?
That's a good question. I would suspect we should probably run that. We should probably run that board through and actually get a price on it. But I expect that'd be a few $100s as opposed, maybe not less than 1,000, but yeah.
Anyone else?
Flexible circuit boards?
Again, this is a question of I think. Well, the software can definitely handle it. We have that. Flexible circuit boards are actually it's actually a really good insight into the way the industry works in terms of this. There's actually no real established standard of a Gerber file for a flexible PCB, so people get all kinds of Gerber files for that. But again, this goes back to the question of, is there enough people out there that want this to do that? Because one of the things we found is that part of the reason the process is so complicated is because everyone tries to offer every single option. So we are following the 80-20 rule, and we're trying to capture those 80% of people. If you have something fancier than that, then you probably have the connections and the know-how to get it done the other way. So I think it's definitely a possibility. I know that there is demand for that, but I think to start, we're trying to start with something easy, so we're doing 2 and 4 to start. So, yes.
2 thoughts. I'm just thinking about the whole process of sort of the whole value chain, and I see you're shooting for obviously when you first make a prototype. One thing is testing. Where are you bareboard testing after your components are on? And then secondly, where do you see yourselves so that you make the first 5 with you, 50 with you, 100? Where do you see yourself on that?
So let's answer the testing question first. So one of the things I think that we are, again, trying to do is we're trying to focus down to what do you really need? And so, there is some testing that we can automate that I think we can do, but if it goes beyond automation, it's one of these questions of, is it worth trying to do everything to cover, 1 or 2 users? And going to the other question of how do we end up landing those big orders? So one of the things we found in customer discovery and is that people don't like to change their manufacturers. They basically have to have a reason. And cost, 5% cost is usually not the reason. It's more like 50% cost, or I hate working with them, or they couldn't deliver on time, or they said they would do something and they didn't do it. So one of the things that we, one of our goals basically is to go from, you prototype with FlashPCB, and then you start putting in a quantity of 1,000 or 100,000, and maybe we call you, and you might go through a traditional ordering process. The other benefit that we have, the way we do it, is that, if you want to do just-in-time delivery, so say, I want to order 10 a month. So the way most other places do it is they'll make all 120 at the beginning of the year, and they'll deliver 10 every month to you. But again, they have to hold that. That's sit on that inventory. So one of the things, the way we can do it is we can allocate inventory. You don't have to make it just yet. We know that once we start getting down below a certain inventory level for your parts, that we will either reorder or hold them for you permanently. And then we can make boards as you need them. So you don't have to have that big initial either. You don't have to pay up front for that, or we don't have to hold credit for you, basically holding inventory for you essentially. So that's one of the benefits there. I know a lot of people do a Kanban style with their manufacturer, so they can pull anytime they want. That works really well for our system. So yeah.
I got another question.
Yes.
Am I allowed to ask multiple questions?
Oh, go ahead. Yeah.
So you said that you're targeting a 3-day turn time.
Mm-hmm.
In my experience, when you order from a PCB assembly house, they say maybe 5 days, 3 days, whatever. But then baked into that is an additional 1 to 2 days of quoting, of back and forth with the suppliers and everything. And then they say, okay, we're kicking off,
Today.
Yeah,
Yep.
kicking off today. And so today's the day that our lead time starts. How much of that can you lop off with your AI? And are you actually able to deliver on that 3-day turn time right now?
So right now, the answer is no, which is why. So we're not promising that. We're trying to deliver on what we can promise here. But 3 days, basically, we see 3 days as starting from when you press order to when it's actually shipped to you. So that's what we see as 3 days. It's not 3 days from when we get the parts in house or all the parts in house. It's funny. A lot of people offer 1-day assembly. JLC, PCB, and PCBWay both, I believe, say 1-day assembly.
That's not like real.
I've tried, and that's not the way it works. It's 1 day of them assembling the board, but it's not 1 day from when I press order.
Right.
So.
I mean, I could offer 20 minutes delivery if we start counting from the moment I walk in the door.
Exactly. Yep. Yeah. I mean, if you start counting the moment it goes to the pick and place machine, it's 1 hour assembly. Yeah. So our goal is that, and actually, it's funny. I'll tell you another little story. At Halo Labs, one of the devices we were building was actually this little manifold to suck that fluid through the filter, and we actually did many iterations of this because it had a contact. We had to make contact because it's a very viscous fluid. So if you don't make contact at the bottom, we don't have enough suction to pull the fluid through the membrane. So once you make contact at the bottom, you break the surface tension. You can actually pull the fluid through. But of course, you can't make contact until you want to pull the vacuum on the actual manifold itself. Anyway, well, there's a long story to this. There's a lot of parameters to go into this. But we ended up making, I think, 10 or 12 iterations of this. And we use a service called Protolabs for a lot of this. Now, they were more expensive than our local machine shop, but they did 3-day delivery for us. Actually, they ended up doing 1-day delivery because we needed it at the end. But there was this relief ordering that I felt when I ordered through them. When I finally got it's about a 45-minute quote process with them. So you upload a file, and 45 minutes later they email you saying the quote's ready. You go look at it. You can add what kind of threading you want on different tapped holes. Also, by the way, they didn't have pipe threading because it's tough to do on a CNC machine. So again, a huge company following the 820 rule. And so 45 minutes later, so typically I'd upload it, go home, place the order when I got home. And I was done for the day, and I could relax. I could think about it. I wouldn't have to think about it until a day or two later it shipped. Now, when I got using my local machinist, of course, I would send it to him that evening, and then of course I knew the next morning I'd have an email with lots of questions. And same thing with the PCB world. There's nothing that says like, hey, you've placed that order, it's going to go through, it's going to get it. There's always this question of like, can they buy the parts? Can they make the board as it said? And I've already paid typically for JLC, PCB, and PCBWay. You've already given them your money. So when they come back and say it's another $200, $300, you do it because they've already got your money. And so, yeah, that's the kind of feeling we want people to have when they press order. They are relieved at that point. So, yes.
Because on the parts, so you're not storing the parts yourself, you're outsourcing them. Will you have a direct link to know that they have the person's ordered in stock? Or?
Yeah, so this is actually a really interesting question, and it's one that we think quite a lot about right now. We've actually chosen our contract manufacturer very carefully because of this. So our contract manufacturer is actually a distributor first. Their surface mount line is simply a value add for them on some of the cable assemblies typically. The other thing is that every online service has API access. So DigiKey, Mouser, Arrow, they all have access through an API. So you can easily check the components that are in stock when you do that kind of thing. And yeah, so that's there. We don't have to hold everything. There may be some components we do have to hold because they're not always available those ways, but I would imagine that most resistors, well, capacitors are a little different story. But yeah, the goal is not to hold as little as possible, but what we do need to hold, I think we will start holding. And if, so say you come to us with a very obscure IC that you want, and we don't think that other people order it, one of our thoughts is that we might charge a small deposit, so when you order your board, that's a deposit towards your order with that component. But that's, again, this is something we're going to discover in our beta phase. We have to test these kinds of things. So, by the way, if you do sign up for the beta right now, we will add components for you for free, so don't worry about that. Any other questions?
Any other questions? Okay, thank you so much.
Thank you.